Okay, here are, I don't have solutions for this exam online, so I thought I'd just make a quick little video. In terms of just quickly here, I'm not going to write the whole thing, but the solvent is the substance it's in the greatest amount. So usually water, eh? And the solute is one in the least amount. And it's been dissolved into the solvent. A saturated solution is one in which you've put as much solute as possible. So the solute's at its max. The molarity is a way we describe the concentration of a solution, and it's always written in moles per liter. And pH is sort of a scale that we use to measure how much acidity is in a solution. So acidity. Okay, on our exam, I have 10 multiple choice questions instead of short answer definitions. So there's 10 multiple choice, but you need to know these, they might be on there. Okay, so some other questions. What is the difference between dissociating and dissolving? So dissolving is when you take a solid, or I guess a powder, or it could be anything, and you put it in water and it disappears. I guess you could say that. But dissociation is the process of an ionic compound. When it goes in water, it might look like it's dissolving, and it does dissolve, but it also dissociates. So for example, if you take calcium chloride, and if you put that in solution, you're going to get calcium 2 ions, and you're going to get 2 chloride ions. So that's an example of a dissociation equation. So dissociation is a substance breaking down into its ion. Whereas if you take a look, just one quick example of dissolving is taking something, say, like salt. Oh no, salt would be ionic and it would dissociate too, but say sugar. So let's take table sugar, C12H24O11. I think that's sugar. Yep. And it's a solid, right, in your container. And when you dump it in water, it does not dissociate, but it does dissolve because it becomes aqueous, or it's dissolved in solution. Okay, concentrated, lots of solute, dilute, not much solute. Arrhenius, we didn't talk a whole lot about Bronsted-Lowry. So Arrhenius's definition is acids are solutions that give rise to hydrogen ions, whereas bases are ones that give rise to hydroxide ions. That's sort of what he said. Buffer, don't worry about that question. You'll do that one in Chem 30. Okay, here we go. It's dissociation equations for the following. So iron 2 sulfate. So iron is a 2 plus, sulfate's a 2 minus. Oh, so they're even Steven. Okay, good. So iron 2 sulfate, it just looks like that. And it would be a solid. When you dump it in water, it'll dissociate into the iron ions, the iron 2 plus ions, and sulfate ions. Okay, calcium chloride, same thing, CaCl2. A solid, when you dump it in water, it forms calcium ions, aqueous, plus chloride ions, aqueous. Now this one, there's a 2 here, so I need a 2 there. If it's a chloride ion, careful with that. If it's a chloride ions are just Cl minus. If you have chlorine by itself and it's not an ion, you always have to rate it Cl2, but not in this case. Okay, what volume water must be added to 30 mils of 11.8 to dilute it to that? Oh, okay, so we're C1V1. So C1V1 equals C2V2. I'm calling this V1 and this C1. So this has got to be C2, and I'm looking for V2. So V2 is what I'm looking for. So V2 will be C1V1 over C2. C1, 11.8 molar, times V1, 30 milliliters. I'm just going to leave it as milliliters because I can see that what's happening here is the molarities are going to cancel, so my volume will just wind up to be milliliters. Okay, multiply, divide, and it looks like you should end up with 3 sig figs in that one. Next question. 25 milligrams of solid iron 2 sulfate is dissolved in 5 liters of solution. What is the molar concentration? Oh, okay. So concentration is moles over volume. I have a volume, but I don't have any moles. But I have this amount of iron 2 sulfate. So I can figure out moles from that. So let's start. Moles are mass over molar mass. So the mass is 25 milligrams. Maybe I'll change the milligrams just to grams. It's more sort of messing my mind. It'd go 3 over to the left. So 0.25 grams, that's not very many, over the molar mass, so I don't know that. So it's iron 2 sulfate, FeSO4. So iron is 5585, sulfur's 3207, I think, and 4 oxygens at 16 would be 64. Okay, so add those together, 9, 11, that's a 6, 151.92. So 151.92 grams per mole. Grams cancel, so I have moles. Now I can use this formula. So moles are whatever this answer comes out to be, divided by the volume, which is 5 liters. And it was nice that I got rid of that milligram, because the concentration should be measured in moles per liter, not millimoles or anything like that. It should be moles per liter. So I think we're good there. Looks like there's 4 sig figs everywhere, so you'd have to give me an answer to 4 sig figs. Next question. What volume of point can be prepared from a mass of 4.5 kilograms cobalt? Oh, wow. So we're looking for volume. Cobalt-3 nitrate. So that's a good one. This is a concentration. They're looking for volume, and they're giving me a mass. So I think I'm doing the similar thing with this one. So mass over molar mass. Mass is 4,500 grams divided by the molar mass. I'm going to have to go over here and do 1 cobalt. Looks like 3 nitrogens and 9 oxygens. Add those all up. That number will come here for my molar mass. And then I'll use my C equals N over V. Oh, but this time I'm looking for volume. Oh. So if I'm looking for volume, it's on the bottom. So I have to get it to the top. I'm going to move it to the left side and put it on the top. And then I'm going to take the concentration over to the right and put it on the bottom. So the mole answer that I get here is going to come on the top there, and my concentration 0.125 moles per liter goes on the bottom. Divide, come up with your answer. It looks like 2 sig figs. So 2 sig figs would be your what you need to round to. Sorry, I've got a phone in the background. Okay, next question. Calculate the mass of solute in 50 liters of 0.035. Oh, so this is a volume, this is a concentration. So it looks like I'm using this formula here, and I'm going to determine moles. So take the volume and multiply it on the other side. So you get moles is equal to C times V. So the concentration, 0.035 moles per liter, times the volume, 50 liters, that's a lot, 0.00 liters, cancel. And so you're going to come up with an amount of moles here. And then you'll use this formula. Moles is equal to mass over molar mass, because they're looking for the mass. So they're looking for this one. So I want to get rid of the molar mass, so I'll take it to the other side and multiply. So mass will be equal to moles times molar mass. The moles comes from right there, times by the molar mass. You'll have to figure that out. So you've got uranium 6 phosphate. That's going to be a hard one to do. This is a 3 minus, this is a 6 plus. Oh, so I just need 2 of those. Okay, so figure out your molar mass of 1 uranium, 2 phosphorus, 8 oxygen, and that goes in for the molar mass. Multiply, and it looks like I've got right here 2 sig figs. Next question. Mass percent formula. Mass percent is equal to the mass of the solute divided by the total mass of solution. And they are wanting to know the mass percent. So the solute, looks like I've got 5.34 grams of the solute, and they're dissolving it in 152 grams of water. Problem with that is, and that messes this up, is that that's just the water, and the bottom number has to be the total solution, total weight of the solution. So when you add those two, you get 157.34. That's the total mass of the solution. You put that in there. Divide them, times it by 100, good to go. Okay, last page. Calculate the pH and PHOH of a solution made by dissolving 10 grams of lithium hydroxide. So I have lithium hydroxide dissociates into lithium ions plus hydroxide ions. So 1 to 1 to 1. So 10 grams of lithium hydroxide. So I'm in this much volume. So I need to figure out concentration first. But it looks like I've got to start with grams. So I'm going to use this formula, mass over molar mass, 10.0 grams, divided by the molar mass of lithium hydroxide. So I need a lithium, an oxygen, and a hydrogen. Add those numbers up. That number comes in right there. And that'll be your moles of lithium hydroxide. Then I'd figure out the concentration of lithium hydroxide, moles over volume. This moles comes down here, divided by the volume of 0.500 liters. And that'll give me a concentration. This number here will give me a concentration of lithium hydroxide. But since the ratio is 1 to 1, that'll also be the concentration of hydroxide ions. Well, this is a tricky question. So now what I would do, once I have the concentration of hydroxide ions, then the next thing I'll do is do the POH, not the pH, because they're giving me hydroxide ions. So POH is equal to the negative log of the hydroxide ion concentration. So whatever number you get from here, you plug in right there. Okay, your answer will come out to something, don't know what it'll be, fairly concentrated, so it'll probably be a fairly high number. And then if you want to figure out the pH, then you take 14 minus whatever that is, and that'll be what your pH is. Okay, let's look at the next question. 20 ml solution of hydrochloric acid found to have a pH of 215. How many grams of HCl must be present? Oh, that's a good one. So what I need to do is to figure out from here what the concentration of hydrogen ions is. So I won't start there. Concentration of hydrogen ions from the formula sheet is 10 to the negative pH. So I'm going to go 10 to the negative 2.15, and that number is my concentration of hydrogen ions. Okay, whatever I get there. Then, let's see, so that's the concentration. I can write out this HCl and dissociate it like this, but notice it's a 1 to 1 to 1. So whatever the concentration of hydrogen ions are, that's the same as the concentration of hydrochloric acid. So now you can take C equals N over V, and I want to figure out moles. So it'll be moles is equal to C times V. So take this concentration, plug it in for C, multiplied by the volume right there, 20 milliliters, 0.0200 liters, times those together. That'll give me the moles of hydrochloric acid. And now I can use this formula, moles is equal to mass over molar mass. I'm solving for mass, so it's moles times molar mass. The moles come from right here, multiplied by the molar mass of hydrochloric acid, which is 36.46, I think, grams per mole. multiply it out, come up with a number. Lastly, Bronsted-Lowry you'll do in Chem 30. Okay, hopefully that helps you with the review for that particular old exam.